Ludlum Measurements has been manufacturing quality radiation detection equipment since 1962. LMI has a wide range of quality radiation detection equipment. This includes handheld survey meters, pocket meters, portal units, not to mention laundry, air, and floor monitors, plus many more. Our objective is to provide a quality product that meets the needs of the user in a package that will withstand rugged usage in harsh environments. To that end, the instruments demonstrated in this video were designed for durability to give many years of service with a minimum of maintenance. Ludlum measurements can be found on the web at www.ludlums.com. Our toll-free telephone number for the U.S. and Canada is 1-800-622-0828. The purpose of this video is to familiarize the user with the operation of the Ludlum Measurements Model 14C-RK response kit. More specific training by a health physics professional regarding survey techniques and limits is recommended. For more information, contact your state radiation regulatory authority, the United States Federal Emergency Management Agency, or visit the Health Physics Society at www.hps.org. This emergency response kit contains the Ludlum Measurements Model 14C survey meter with a cesium-137 check source mounted on the side, the Model 44-9 Geiger-Müller detector, the Model 44-2 sodium iodide gamma scintillator detector, a detector cable, and 2 D-cell batteries, all stored in a hard protective case. The Model 14C is a ruggedized portable survey instrument that operates on 2 D-cell batteries. The instrument features a regulated high-voltage power supply set at 900 volts and provides 5 linear ranges to 2,000 milliAR per hour. The operator controls are clearly marked on the front of the Model 14C. The audio on-off toggle allows the operator to turn the instrument audio either on or off. When on, the switch energizes the unimorph speaker on the left side of the instrument. The number of clicks is relative to the rate of the incoming pulses. The higher the rate of pulses, the faster the audio clicks will be. The audio should be turned off when not needed in order to reduce battery drain. The fast-slow toggle switch changes the meter response time of the instrument from fast to slow. In the S position, there is a fast response and a large deviation. In the S position, there is a slow response and less deviation. The reset button, when depressed, provides a rapid means to drive the meter back to zero. The battery check button, when depressed, provides a visual means of checking the battery charge status. The instrument must be turned on to do this check. There is a connector used to connect the detector to the instrument with a coaxial cable. The detector operating voltage is supplied to the detector via the detector input connector. A mild electric shock may occur if you make contact with the center pin of the input connector. Switch the Model 14C range selector switch to the off position before connecting or disconnecting the cable or detector. The range multiplier selector switch is a 6-position switch marked off, times 1,000, times 100, times 10, times 1, and times 0.1. Moving the range selector switch to one of the range multiplier positions provides the operator with an overall range of 0 to 2,000 milliroentgen per hour. Multiply the scale reading by the multiplier for determining the actual scale reading. An internal energy compensated high-range detector is used for the times 1,000 range position only. If the radiation level being detected by the internal detector is greater than 10 R per hour, the instrument indicates over range or full scale on any range setting. This is a safety feature of the Model 14C. The Model 14C has an overload circuit built in that will keep the meter at full scale even in very high radiation fields. The calibration controls have a protective cover to prevent tampering. They are recessed potentiometers which are used to calibrate the individual ranges selections and allow for high voltage adjustments from 400 to 1500 volts. To read the meter face dial, multiply the meter reading by the range multiplier setting. The dial on this Model 14C-RK has 3 arcs to show count rate or exposure rate, a CPM or counts per minute scale, a linear milliAR per hour scale, and a nonlinear milliAR per hour scale. The top CPM scale is valid for the times 0.1, times 1, times 10, and the times 100 ranges. The middle linear milli-hour per hour scale is valid for the times 0.1, times 1, times 10, and the times 1000 ranges. The bottom nonlinear scale is valid for the times 100 scale only. In this example, reading the top CPM scale, the meter needle is on the 5K tick mark, and the range selector switch is on the times 0.1 setting. The reading will be 5K CPM or 500 CPM. Changing the range selector switch to the times 1 setting will change the reading to 5K CPM or 5,000 CPM. Changing to the times 100 setting, the reading will be 500K CPM or 500,000 CPM. Remember that this scale is not valid with the times 1000 range setting. In this example, reading the middle milli-hour per hour scale of the meter needle is on the 0.5 tick mark, and the range selector switch is on the times 0.1 setting. The meter reading will be 0.05 milli-hour per hour. Moving to the times 1 position changes the reading to 0.5 milli-hour per hour. Moving to the times 10 position changes the reading to 5 milli-hour per hour. The middle scale is only valid with these 3 settings. In this example, reading the bottom nonlinear milli-hour per hour scale and the range selector switch in times 100 position, the meter needle is on the 1.5 tick mark. This will be read as 150 milli-hour per hour. The Model 44-9 pancake detector will detect alpha, beta, and gamma radiation. Its size and shape provide easy handling for surveying or personal monitoring. It contains a tube filled with halogen-quenched gas and has a thin mica window. The thin mica window is protected by a stainless steel screen. Caution should be taken when using the detector around vegetation or any sharp objects. The thin mica window is easily damaged. The plastic cover should be used to protect the window when not being used. The GM tube can easily be removed for replacement if necessary. The Model 14C response kit also contains a Model 44-2 sodium iodide gamma scintillator. It consists of a sodium iodide crystal coupled to a photomultiplier tube and is housed inside thick aluminum. The Model 14C operates on 2 D-cell batteries with a typical battery life of 2,000 hours. Change the batteries as soon as possible when the battery voltage becomes low. The Unimorph speaker will emit a continuous audible tone to warn of imminent battery failure. For extreme cold environments, very fresh alkaline or rechargeable nickel-cadmium batteries are recommended. Remove the batteries if the instrument is to be stored greater than 30 days. To install the battery, first make sure that the range selector switch is in the off position. Open the battery compartment lid by pushing down and turning the thumb screw 1/4 turn counterclockwise. Note the negative and positive marks on the inside of the lid. Install the batteries matching the battery polarity with these marks. Reversing the battery polarity will not harm the instrument, but it will prevent it from functioning. Close the battery compartment lid. The standard detector cable sent with each kit is made from coaxial cable with C-style connectors at each end. Connect one end of the detector cable to the instrument by firmly pushing the connectors together while twisting clockwise 1/4 turn until it latches. Repeat the process in the same manner with the other end of the cable at the Ludlum Model 44-9 detector. The batteries should be checked each time the instrument is turned on. Move the range select to the times 1000 position and press the back button. Ensure that the meter needle deflects to the battery check portion on the meter scale. If the meter does not respond, check to see if the batteries have been correctly installed. Replace the batteries if necessary. After checking the batteries, an operational check should be performed to ensure proper operation between calibrations and periods of non-use. Turn the range switch to the times 1000 position. Turn the audio switch to the on position. Expose the internal detector to a check source. The Unimorph speaker should emit clicks relative to the rate of counts detected. Turning the audio switch off will silence the audible clicks. It is recommended that the audio be kept in the off position when not needed to preserve battery life. Turn the range selector switch to the times 0.1 position. Turn the fast-close toggle switch to fast. Expose the Model 44-9 detector to the check source mounted on the side of the Model 14C. Rotate the range switch through the lower scales until a meter reading is indicated. The reading should be within 20% of the initial reading taken during calibration. This reading can be found on the calibration certificate sent with your response kit or on the calibration sticker on the side of the instrument. If the current reading fails to fall within 20% of the reading taken at calibration, the instrument should be recalibrated. Pull the detector away from the check source for a few seconds and then return it to the test position while observing the speed of the meter-needle response. Again, pull the detector away and wait a few seconds. Toggle the fast flow switch to the slow position and return the detector to the test position while again observing the speed of the meter-needle response. The slow position should respond approximately 5 times slower than the fast position. Toggle the fast flow switch back to the fast position. The slow response position is normally used when the instrument is displaying low numbers, which require a more stable meter movement. The fast position is used at medium to high rate levels. The fast response position of the fast flow switch is the normal position for emergency response work. Check the meter reset function by depressing the reset push button switch and ensuring that the meter needle drops to 0. When released, the needle should return to the current reading. Once you've completed these operational checks for the Model 44-9 detector, change over to the Model 44-2 detector and repeat the same procedures. Ensure the final reading is within 20% of the reading taken during calibration. Once these operational checks have been performed, your Model 14C response kit is ready for use. In this next demonstration, the Model 44-9 will be used to show the detector's response to different types of radiation. Remember that the Model 44-9 detector will detect alpha, beta, and gamma radiation. Turn the audio switch on the Model 14C to the on position. Turn the range multiplier switch to the times 0.1 position. The Model 44-9 is held with the detector surface a few inches from an alpha source and moves slowly around to survey the entire area. The CPM scale is always used for measuring alpha radiation. When the detector approaches the alpha source, the audio count rate in audio clicks will increase. Every time the needle is driven to full scale, switch to the next higher range multiplier position. Notice that the alpha particles are only detected when the Model 44-9 is moved very close to the source. Alpha particles only travel about 1/2 inch through air. An alpha particle has 2 protons that give it a double positive charge. It has a low penetrating power and short range. It is also a large and heavy particle when compared to other subatomic particles. Because of the double electric charge and the mass, the alpha particle is highly interactive with matter. This means that an alpha particle cannot penetrate deeply into material. Because of this, the alpha particles will generally fail to penetrate the outer layer of human skin. If the alpha particles are inhaled, ingested, or absorbed through a wound, they can cause internal damage to the organs. Therefore, alpha particles are considered to be an internal hazard only. Outside the body, the alpha particles present little or no hazard at all. The alpha particles can be blocked by a thin piece of paper because alpha radiation is not penetrating. If the count rate is reduced when the paper is in place, then the source is mostly alpha radiation. If the count rate stays the same or only drops a little, the main part of the radiation is not alpha radiation. Remember, during this test, the detector will still be picking up background radiation. A beta source is now being surveyed with the Model 44-9 detector. The CPM scale is always used when measuring beta fields. Turn the range multiplier switch to the times 0.1 position. As you can see, the detector is able to detect the beta particles from a much greater distance away from the source. Every time the needle is driven to full scale, switch to the next higher range multiplier position. Beta particles can travel several feet in the air. A beta particle is an electron that has half of the electrical charge of the alpha particle and much less mass. A beta particle has moderate penetrating power and a range of up to a few meters in air. Beta particles will penetrate the dead layer of skin and damage living tissue. This is called a shallow dose. Therefore, betas are considered both internal and an external hazard. Any dense material, such as metal or plastic, can be used to shield beta particles. Turn the range multiplier switch back to the times 0.1 position. A gamma radiation source is now being surveyed with the Model 44-9 detector. Gamma radiation does not contain any mass. Instead, it's an energy wave level like light, which can travel thousands of feet in the air. The Model 44-9 can detect gamma radiation from as little as a few inches to several feet away from the source. The detection range depends upon the amount and the energy of the gamma rays. As the detector is moved closer to the source, the count rate in audio clicks will increase dramatically. Every time the needle is driven to full-scale switch to the next higher range multiplier position. Gamma rays are the most penetrating type of radiation and can penetrate the human body, causing internal damage to body organs. Therefore, gamma radiation is considered to be an external hazard. Very dense materials such as lead, concrete, and depleted uranium are the best for shielding gamma radiation. This sheet of aluminum will partly attenuate the gamma radiation but will not block it completely. Now let's change over to the Model 44-2 gamma detector. Remember that the Model 44-2 will only detect gamma radiation. Turn the range selector switch to the off position to prevent electrical shocks in the internal pin of the cable. Disconnect the Model 44-9 and replace with the Model 44-2 detector using the same cable. Make sure that the audio switch on the Model 14C is in the on position. Turn the range multiplier switch to the times 0.1 position. The Model 44-2 is much more sensitive to small amounts of gamma radiation. Therefore, it can detect a gamma source from a further distance away than the Model 44-9 detector. It cannot, however, detect alpha or beta radiation. When surveying with the Model 44-2 for gamma radiation, use the cup CPM scale only. Notice how the Model 44-2 is held while surveying. The end of the detector should be facing the area being surveyed. The detector is moved slowly around the area while watching the meter needle and listening to the audio clicks. Every time the needle is driven to full scale, switch to the next higher range multiplier position. Now that you know more about the survey instrument, here's a brief introduction to exposure and dose measurements as they apply to gamma radiation. A Roentgen is a unit of exposure from X or gamma radiation in dry air. RAD is an acronym for radiation absorbed dose. RAD is a measurement of energy deposited in any material from X or gamma radiation. REM is an acronym for Roentgen equivalent man. It's a measure of the damage caused when gamma radiation interacts with the human tissue. For gamma radiation, 1 Roentgen of exposure is approximately equal to 1 rad of absorbed energy. This equals 1 rem of biological damage in humans. Contact your local, state, and/or federal authorities for guidelines on radiation exposure limits for first responders. Due to the sensitivity of the instrument, it is possible to measure radiation levels that are not generally considered to be hazardous to health. Exposure to radiation levels of even 1,000 times normal background radiation or more may be permitted by your guidelines without any health effect. To prevent overexposure, remember time, distance, and shielding. The length of time spent in a radiation field is directly related to the dose received. Always try to minimize the amount of time spent near a radioactive source. The distance between you and a gamma source will also determine your exposure rate. The inverse square law applies to gamma radiation sources. This means that if the distance away from the source is doubled, then the exposure rate will be reduced to 1/4. Simply said, the further away you are from the gamma source, the less exposure you receive. Moving a few feet away from the source of radiation can reduce the dose rate. Shielding yourself from radiation is another way of reducing the amount of exposure. The material between you and the source will lower the radiation dose you receive. The denser the material, the better it shields the radiation. To keep the exposure as low as reasonably achievable, use time, distance, and shielding. The Model 14C survey meter does not require any scheduled maintenance. There are no internal parts requiring scheduled replacement. The instrument should last for many years without need of repair under normal circumstances. Battery and cable replacements aren't considered to be maintenance and do not normally require the instrument to be recalibrated. Check the calibration sticker before each use to ensure that the calibration has not expired. Ludlum Measurements recommends recalibration at intervals of not greater than 1 year. Check your local, state, and federal regulations to determine required recalibration intervals. Never store an instrument over 30 days without removing batteries, as battery leakage can cause corrosion on the battery contacts. The three most common repair problems with your Model 14C survey meter are loss of battery power, a noisy or upscale reading, and detector breakage. Loss of battery power can come from corrosion on the battery contacts caused by leakage of the battery acid. Avoid this by removing the batteries during storage. Fix the problem by scraping off and or washing the battery contacts with a diluted baking soda paste. The next problem, noisy or upscale readings, can be caused by a noisy cable or breakdown of insulation within the cable. Detect this problem by replacing cables or swapping cables from another instrument. Replacement of the defective cable is necessary. Detector breakage is another frequently seen problem. The Model 44-9's window is very thin and can be easily punctured by anything that sticks through the protective screen, even a dry blade of grass. When the window is broken, the instrument will read 0. A similar problem occurs when the Model 44-2 detector is dropped or receives a hard shock. The internal glass tube or crystal detector may be broken. Again, the result is a detector with an erroneous reading. In each case, the detector must be repaired at Ludlum Measurements. Ludlum Measurements provides repair and calibration services for these and many more instruments. If you have any questions about products manufactured by Ludlum Measurements, our sales and technical staff are available by telephone to assist you. Our toll-free telephone number in the United States and Canada is 1-800-622-0828. Ludlum Measurements can be found on the web at www.ludlum.com.